All right, so first thing's what I need you guys to do for your flip charts, okay? This is very important. This will be something that not only along with your periodic tables that you always have, you'll always be, for this unit, always be able to have it in front of you. And anytime we have to do any type of naming of any type of compound. So first things first, you take this piece of paper and fold a hot dog. So fold it just like so, increase it, just like so. Very simple, okay? Okay. Then, just basically make, and how I did it was then I just took like this, and I'll show you, and I'll hold it up in a second. Then I just basically, nice and easy, took this and made like, you don't have to be everything, but just made just 3 little flats. So I ripped like this, so you had, so it looks like this. So I ripped up like this, so I have little flats, okay? So you should have like 3 little tabs, okay? Like so. All right, everybody seeing that there? Has a little, like a little desk thing there, okay? So first things first, that's how it should look, okay? Pretty simple there. What's so far with that? Got the little tabs, got the hot dog shape, everybody like that, okay? All right, make a little crease there for, however you want. If you wanted scissors, you could do the old formula with the scissors of that, but however you want to do it, okay? But it should look something like this with little tabs, okay? All right, everybody see how that works? Okay, everybody got that? Little 3 tabs. Okay, so, with my back here, so be on your farthest left tab, this is looking at the outside of this folder like this, okay? Here's what I need you to write on the outside of your flip chart. And I had mine I made earlier like this, okay? So you're going to write on the outside of the flip chart, real legible, ionic compounds. So that's on the outside flip part, okay? You're going to write right here on this one, ionic compounds. Then you make this little bracket and write the words metal to non, bracket. And then you can make this little symbol below. It looks like a stair step with an arrow pointing that way. And above that's going to say first element, okay? So I'll repeat that if you can't see it all the way over there. Ionic compound, I-O-N-I-C, ionic compounds. And then below that, little brackets, metal to non, metal to non. Then you make that little stair step symbol here. Choo, 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 choo. Arrow pointing back this way. And then above that, put first element, okay? That's going to be the outside of that first lip for me, guys and gals. All right? Give you a few minutes there. And this is just a formality that I'm going to teach you how to, when we're all got this filled out, I'm going to teach you exactly how you'll use it, and it'll always be able to, yes ma'am. Which one, right here? It says ionic compounds, metal to non. Metal to non?
No, first what? By the stairs.
Oh, first element, sorry, yes, first element thing, sorry about, my little chicken scratch there, First element is what it says above the little arrow there. I'll rewrite that little element, make it look nice and neater. First element. Okay. All right, so that should be on the outside of your first tab. So then the middle tab, you're going to write same thing, but on the middle here, this one right here, you're going to write across the top molecular, M-O-L-E-C-U-L-A-R, molecular compounds. Below parentheses, the same as saying covalent, which is spelled C-O-V-A-L-E-N-T, covalent compounds. So it's going to say molecular compounds, parentheses below covalent compounds, same thing. Okay? Then you're going to write little brackets like you know the other one. It's going to say non to non, non to non. And then the same thing, you're going to make your little stair step with the arrow pointing this way, and it's going to say first element like you did on the other one. Okay? Real similar to what we did on the first side, just a little tweaked, a little different on the other side. And then we won't put anything for right now, it's not necessarily on the third tab. Okay? The third tab will just leave blank. Okay? If we get to it, which we don't have to, if I feel like we're going well, I'll teach you how to name acids, compounds like hydrochloric acid, bromic acid. Yes, ma'am?
What is the parentheses say again?
This here, non, N-O-N to non.
Like parentheses.
Here, covalent, C-O-V-A-L-E-N-T, covalent. Yeah, Mike, you bet here. Right there, covalent. Okay, covalent compound, non to non, stair step symbol, arrow pointing across, and then first element there, okay? So those are on the outside of the two first lips, okay? All right. No worries there. Okay. So then what we're going to do, all right, is I'm going to explain this outside lip just for a second, but we're going to go back over, but I'm going to go as we go before we flip it up and write the rules. So what this is meaning, guys and gals, for this first thing is you're going to use these rules, all right, when you answer this first little question. So this is actually a little question, okay? So over here on your periodic table, you have, if you haven't got it out already, go ahead and drag out your periodic table that I gave you. Or if you need one, holler, I got some extras, okay? But have that out in front of you because I want you to make some marks on it for me, okay? All right. Everybody should have one. If not, I can find some more. I got a bunch of them. All right, let me know if you need one. All right, so looking at that periodic table, as all of you got that out, you got something. All right. So, let me get my makeshift pointer right here. Used to be part of another tripod now. You need one?
Yeah. Yeah, can I get one too?
Okay. Did I put the extras over there? I think I put them over here. Miss King, could I ask her a big favor?
What's that?
I am. Yes, please. Let's use this one because it's already got some marks on it for him.
Okay.
And that will save space there. Just put it in a single cut like twice. Just
Want
side
me
by
to
side.
go to, I'm thinking you color, so it'll show, this will show up or no?
If you want, if you
No, I
can.
don't think that'll show up.
Yeah,
right?
if color, it doesn't matter because they can color it like that just so they have it. Okay. All right, so you guys just bear with me, pay attention. I'll get you an extra color in here. Miss King's gonna help me out. I thought I had a whole nother stack of them there, but they must have disappeared. Or I've been giving away. Okay, so let me get my makeshift pointer. Okay. This used to be a microphone that was on the stand and it broke, so I thought, oh, I'll just use this pointer. Okay, so here's what we're talking about right here. That little stair step symbol. See this right over here where boron's element number 5. Right here. So you want to make sure and trace this, make a distinct line, stair step, on your periodic table. They call it the stair step. Okay? So right there starts at boron. You're going to go down, across the top of aluminum, down silicon between them, across germanium, down arsenic, across antimonium, down tellurium, across polonium, and down astatine. Condominium. It's kind of a tongue twister. Okay. So, what this is telling you, troops, is with this stair step, the first question, as you're looking right over here, is, it says exactly what I need you to do. Whatever the compound is we're wanting to name, you look at the first element. So for example, i.e., let's say this was written in front of you and you had to name it. Although many of you are going to say, that's sodium chloride. Okay, let's say you don't know that, but you got your periodic table. So you'd say, all right, which rules do I use? Meyer hasn't showed them to us yet, but the first step would be looking at my chart and I'd say, okay, he says right here, look at the first element. Boom, that's the first element, right? Everybody agrees, sodium. It says, I look at my little stair step without tripping over everything. Here's my stair step. According to my little diagram, is sodium Na on this side or this side of the stair step? It's right there. So that means I would lift up this tab, and we're getting ready to write down these rules I'm going to explain them to you. So that means, because that was the first rule Meyer showed us, those are the rules I use to name this compound. Okay? Step 1. All right, so, i.e. example. Now we're going to lift up that first lip, just like we had. You remember all that ionic stuff there? You're going to lift this up, and right here is you're going to, this is like a giant flip chart. You're going to make these simple first rules. Okay, and I'll take some, I won't talk too fast or I'll take my time here. But the first thing you write at the top is right here underneath this flip. Rule number 1, name the cation. And then I put in parentheses, that's the same as the first element. Remember, the cation is the first element in a compound. So you name the cation. Not cation. Okay, name the cation, first element. Okay? That's the first rule of using an ionic compound to figure out what it has named. Okay? Just write that at first main rule. 3 simple rules. Okay. All right. Name the cation, which is the first element. That's what it says in parentheses. Name cation, parentheses, first element. Okay? Then the second rule says right there, okay, this is where I ask you a question. Basically, I ask no question as to what part of 2 you do. Is the cation, that's D, the letter D, capital D, a D block, BLK is just abbreviation for block, or a capital P, a P block metal? Okay? Who needed a stair step again? 1, 2. Oh, look at you. No, where'd you go?
These are just my office that I've used with my kids in the past.
Nice.
Can I pass them out?
Yeah. Yeah, because I already got, it's fine, that, and they're in a little sleeve. And,
Yeah.
yeah, go ahead.
I already got new ones.
Yeah.
I found these from my office that I used last year, so.
Yeah. Awesome.
Hopefully I have enough.
And if we want, we can, should we just keep those as permanent ones in here and then they let them take the other ones home? Yeah, that'll be perfect. So let's give you, and then you two. So those ones in the sleeves that this King's giving you, and this is the one you can write all up and keep that. The ones with the little sleeves. Yeah, the ones, this will be your permanent one. Leave the little sleeve ones on the desk. That'll be a classroom set. That's a great idea. It's got good color codes. Okay, so look at a rule 2, like I said. Is the cation a D block or a P block metal? That says parentheses, little arrow, bottom of the stairs, which I'm going to show you. Bottom of stairs, that's going to show you. Or cation D block groups 3 to 12. That says groups, parentheses, 3-12. Okay, that's the first question I'm asking you about rule number 2 of this. Is the cation a D block, which is 3 to 12, groups 3 to 12, or a P block, which is bottom of the stairs? Okay? Thank you. Okay, so as we're writing that, on your own writing down chart, or those really cool color ones that Ms. King just gave you, looking at either one or both, here is the key of what they call a D block metal. Or, I think you helped me with that, didn't you, when I said, what's transition mean? Yes, yeah, that was you, yeah. When I said a D block, or aka transition metal, are metals that don't always have the same charge. Thus, they transition, as she confirmed that for us, okay? So Emma done that. So, when it says parentheses 3 to 12, can you see okay past me? Okay, I'll just move on. But this is what I mean. That's what I mean, groups 3 to 12. So that means this little rectangle right here is all what they call transition metals, okay? That's what it means, D block, aka D block. So if you wanted to write that on your own, if you haven't already, you can put that for as a reminder. You can put a nice colored block around that to remind you those are D block metals, if you want to as well. The P block, as I said on my key there, says, kill myself. Oh yeah, I keep running into it. There we go. Now he's clear to see that. The P block are right over here, troops. When it says bottom of the staircase, here's what I mean by bottom of the staircase. So basically, if you went straight here down from aluminum to thallium, across to polonium, that little stair step, that's what I meant, the bottom of the stair step. So it's these 1, 2, 3, 4, 5, 6, 7, 8, like these 10 elements right here. These are the P blocks. P block right here. Choop. So this little step, what I said, bottom of the stair step. So that's a P block metal. 4, 3, 2, 1. Okay, like a little stair step, okay? All right, that's what I meant by the little symbol that says bottom of stairs, okay? So, we're asking ourselves a simple yes or no question, okay? And since we use sodium chloride as our example there, we'll come back to that one too as well, okay? And use that, and I'll use that for the example, but we'll keep going the rules. So then, right below that, you have a yes or no question you're gonna ask. If yes, this will make sense. If it's yes, the answer to this, if it's a D block or P, you're going to find charge. That says find charge. And that's not crisscross, that's cross-criss. That's the only way we used to say it to reverse it. So you're not crisscrossing, you're cross-crissing. That's why I made the little arrows go in the opposite direction. Instead of bringing down the charge, I'm undoing the charge. So we find the charge by what we call cross-crissing, or uncrossing, reversing it, okay? And why do we do that? We do that to find the cation, which we know is the first element, its charge. And once we find that charge, because remember I said it's a transition or p-metal, it can be different. That's why the special rule has to be that we use a Roman numeral. Remember, Roman numerals are, things like this. Like I had on my shirt, Super Bowl. Like those are Roman numerals for the Super Bowl last year. This or 1, 2, 3, or this is 4, this is 5. Yeah, so that's what it means by Roman numerals. Okay. All right. And then once I've done that, which it'll make sense, and we're going to start jumping in with both feet on Monday and learn to do this, you'll be like, oh, this is easy stuff. All I got to do is follow these simple rules, answer these simple questions. Is then when I've done that part, which I haven't done examples yet, you'll just then go to rule number 3. Done. Okay? But if it's no, if when you ask this question, it's no, you don't have to do any of this, go right to rule number 3. Well, that's easy too. So the key thing about ionic compounds is finding out if that first element is a D or P block metal. Yes, you follow those rules there on the yes quote, and I'll explain all that. If it's no, you just go right to rule number 3. No big deal. Okay? So then on rule number 3, you name the anion. Okay, you writing this down? Sure? Come on, where's your flip chart? Why didn't you fold? Come on now. Dang. Unacceptable. I'm sitting here talking to myself and I look up there and you're just looking at me. All right? You should have already. Now you're way behind. You haven't done this. You didn't fold it. You didn't rip it. You write that somewhere. You're just staring at me. Come on. All right? So you're going to name the anion. A-N-I-O-N. Anion. Okay? Which is the second element. Remember? Second element. First element, second. The anion is always the second one. And when you name that, because it's part of a compound with a charge, you take the ending and change it to IDE, like we learned in the notes yesterday. So, for example, chlorine would go to chloride. Fluorine would go to fluoride. Just change it to IDE. It's kind of like conjugating verbs, where you change how it's being interpreted with the thing. And that would be it. Okay? That would be it. So now, let's take that example I gave you a second ago of sodium chloride over there. All right? So we determined the first element is on that side. So we lifted up our chart, and now we're looking at sodium chloride, and we're going to ask ourselves, is sodium a D block metal, yes or no, or a P block? D block is 3 to 12. It's in block number 1. Yes or no?
No.
No. So yeah, right off the bat. So it's no, so I go right to rule 3. Well, that's easy. I didn't have to do all that cross-christen and stuff Myra talked about. So then, I go to rule number 3. So we know this is sodium. Like I said, we named it sodium. Anion's taken care of. Part 3 says that name the anion. Okay, so the anion is chlorine. And all I got to do is says change the ending to IDE. So chlorine would go to chloride. Done. That's all there was to it. Now, that's an easy one. And they're not all up, but that's an obvious one there. Sodium chloride. Okay? All right? Let me give you another one here real quick for this. All right? That's an example of sodium chloride. Before we use the Roman numerals, I'm going to do a couple practice with my purple. This one right now. Yeah. Where's the purple one? It's in my back pocket. Okay, let's pick let's do this one. A, B, R. KBR. We're going to name that. Okay? Some of you may know it, some of you may not. Be like, I don't know. It doesn't matter because Myra just gave you the rules on how to name this. So first things first. I'm looking at KBR. My flip chart's closed. I look at the first element in K. It's right here. Yeah. So is it on this side of the stair step? Yes. So I'm going to use the ionic rules. Okay? Boom. That's easy enough. Boom. Flip on the chart. So then I start asking myself these. The cation, which is the first element. We got that determined. Name it. That is potassium. Okay? Simple stuff there. Simple question. Next, I ask myself, is the cation a D block or a P block? So if it's here, is it 3 to 12? No. And it's not a P block, so no again. So that's easy. No. Go to rule 3. Name the anion. Br, well, I don't know off the top of my head, so I just find it on the periodic table, which is right here. Oh, bromine. Okay. So, bro? What's up, bro? Bro? Okay, bro. So, got bromine. I changed the ending from bromine to bromide. So, it's just going to be B-R-O-M-I-D-E. Done. Potassium bromide. Done. Very simple. Okay? So, you see how easy it is. If the first element, the cation, is not a D or P block, shoot, I just name it pretty much as I see it. Okay?
Yeah, but what if it is in a D block?
What's that?
Like, can we do an example where?
That's what I'm getting ready to do.
Oh, okay.
You're on it, Torres. Yeah. So this, you see how simple that is, right? Okay. So Torres goes, well, what if it's a D or P? That's what I'm getting to right now. Okay. So now I'm going to explain if it's a yes answer. Okay. All right. So let me give you one here. And this is where I've been saying all semester about the charges and stuff. So we're kind of double dipping. I'll start really talking the importance about these pluses and negatives up here. It'll make sense because it's all about opposites attract, how to form those bonds, okay? So let's pick, let's go with, okay, I'm gonna go with, so I do this right, I'm thinking to myself before I write it out. Okay, all right. So here is our element. Okay, CrCl2. Okay, CrCl2. You're like, I have no idea what that stands for. Yes, you will in a second because you got your periodic table in front of you and you got your flip chart. You got all the necessary proper cheat sheets in front of you to follow them right. So all you got to do is say, what does Meyer tell me to do? And I'm learning the steps. So first things first, I look at the first element, which is Cr. And I find Cr on my periodic table, which is right here, chromium. Is it on this side or this side of the stair step? That side. Okay, so I'm using the rules I already showed you. So flip that up. First rule says name the cation, which is chromium. Chromium. Okay? That's easy enough. Rule number 2. Is chromium a D or P block? It's here. So yes, it's a D block. It's right in here in this 3 to 12. Okay? So we finally have something that says yes. Here's where you start getting this now. Okay? Everybody paying attention?
Yeah.
All right, and I'm filming this too, so you even have it on that if you miss something. Okay? So, the key thing here is find the charge and uncross it so you don't put a Roman numeral because you're only going to use the Roman numerals when you have a D block or P block cation. That's the only different rule that you have to learn here. Okay, so everybody's paying attention. So I have chromium. I'm going to find the charge. So basically, it tells me uncross the charge. Looky here, troops. This is not hard. Uncross it. 2 goes up here. This would have been a 1. Obviously, that must be a 1 or a negative charge because that's how it works. So, by uncrossing the charge, that tells me this must be chromium 2. So, use a Roman numeral to represent the number 2. Here it is. Ready? Ready? This is tough stuff. Hey, that's all I had to do. Put a Roman numeral. Chromium 2. So, what that tells me is chromium, that metal that's a D block, particular one has a +2 charge. Okay, because it's a transition metal, and it can have different charges. That's why it's in that rule. That's why we use Roman numerals, and technically you put parentheses around it too, so you don't get it mixed up. That's okay. I'm just happy to get this point. But you see how I did exactly what I showed you in the diagram. I uncrossed them to find the charge of the cation, and then I made that a Roman numeral. The charge was a 2. I put a Roman numeral 2. Boom. Then it says, then go to rule number 3. You're already experts on that. Name the anion, which is chlorine, Cl, and put ID up, so now this is chloride. Chloride. Boom. So, this Cr, when you saw this on a worksheet, and it was this, and I asked you to name it, and you followed your flip chart, that is chromium 2 chloride. Boom. The only thing that takes is this answering yes and no questions, all right? So this is where, guys and gals, if you're paying close attention, it's where there's that learning gap between you and me, and I'm trying to bridge it. You guys are so used to Googling everything, and it does it for you, you don't know the order of operations. Some of you are better than others at that, or you get it. So this is where giving you a different way of, if I do this, this, and this I solve. It's, it's like a checklist, okay? Like if you were a mechanic, and you took your car and it wasn't working, if I was a mechanic, I said, oh, let's check the carburetor, let's check the battery. You just start problem shooting it, okay? When your phone hasn't worked, and you're like, what's the first thing you do? A lot of times you guys just shut it off, shut it back on, take the battery out, put it back on. You know, these little things, the things you know what to do. That's troubleshooting, you're problem solving. So in this particular case, by showing you these steps instead of going, typing in CrCl2, what is its name? Return, chromium 2 chloride. Write it down, go to the next question. You never learn it, okay? All right? Or most importantly, is it irrelevant? Is it the thing that you have to learn? It's that problem-solving part of when you're given a dilemma and you have to go, and I hear this all the time. I'm doing this 24 years, okay? And I hear, you're right, Mara, it's not hard, but I didn't know how to get started. And it's not your fault, and I'm not making an excuse. I never ever do that, but we get so used to doing things a certain way, and that is using computers all the time to do everything. We don't take the time to learn something on how we got that answer. And you have to find a comfortable balance between both ways. That'll make you more well-rounded. Now I sound like a wet bee running a wall. Now I can't walk. I'm from Boston all of a sudden now. Okay? All right. That will help you as you transition out of this and you're out there. You know, there could be some times you're going to have those jobs and positions where, hey, this is my dilemma, figure it out, and the boss walks away like, okay. Right? I mean, fortunately for myself, this is so much easier for me. Is even as a young person your age, and the generation I grew up in, it was already easy for me. So problem solving or saying, build this, fix this. I've already got through a reputation like that. Who has Miss Scott for Spanish? Anybody? Anybody have Miss Scott? Ever have? If you walk in her room, she has a double monitor. You notice one of her monitors is mounted with some washers and brackets. Right before you guys came back, she needed a double monitor, kind of like what I use there, and she couldn't figure it out. And she comes down and she was emailing. She goes, "I know you can fix everything because that." So she brought it to me. I said, "Yeah." I took it home. It took me 10 minutes. I drilled out an hour and 4, no big deal. And then the other day, Miss Doblos, comes in and goes, "I know you fix and remodel things and stuff." She was asking me a question. It's just one of those things. I really like doing that kind of stuff. So, and I know a lot of that stuff, but I've never met anybody that figures out another way to do something or solve something. Go, man, this really sucks that I figured out how to do this. God, I just no. You're like, yeah, I figured that out. Yeah, I knew how to do it, but I figured out a whole other way how to do it when I didn't have this to work for me. Right? So that's what this is. It's that process too. A lot of it is that problem-solving part. Okay, and then applying it. So getting a grade, if you just say, follow these steps, answer these simple questions. First this, okay, it's on this side. I lift this up. I'm going to follow these rules because Myers said, and it said, and I figured it out. The first element's on this side. These are the rules I used to name this. Okay? All right? And then you said, okay, is a cat on? I did it. Yes, no. Bing, bam, boom, done. Okay? All right, let's do another one like this real quick. All right? Then we'll go to the second set of rules. Then we'll be done. I will not have you guys solve some, but it's enough for today, process, and we'll be on the same page with everybody next Monday. Okay, let me pick another one here. Let me see. Let's go with. Okay, so let's use the one that was in your notes. I just remember that, which would be FE203. That one, I think that was the one in your notes yesterday. Okay, I think it was. Yeah, I think it was. Okay, so first things first. I don't know what that is. That's fine. You got the rules to naming chart. I made it for you. So you ask yourself, look at the first flip chart. Ionic compound is the first element on this side or this side of the stair step, as we already know because we're working on that. Iron's right here. It's on this side of the stair step. That's the rules I'm using. Flip up the chart. Okay? All right, so we're definitely ionic. So first things first. What's the cation? Fe, number 26. That's iron. So I write iron down. Iron. Name the cation, just like Myers said. Boom, got that. Now I'm going to ask that yes or no question. And everybody's going to answer this. Is iron a D or P block metal? Yes or no, guys and gals?
The D block.
It is a D block because it's right there. There's the D blocks. Boom. So I'm answering that yes. So I'm going to do the uncross, and I know because it's a D block, there's going to be a Roman numeral for the charge. So let's figure it out. So real simple, I'm going to uncross the charge. So that means the 3 goes up here, the 2 goes up here. So what does that tell me? 1, 2, because I uncrossed, that must mean that's iron 3. See the Roman numeral? Okay, I only use Roman numerals on D and P block metals. That was easy. I uncrossed out. That's my charge. Okay, go to rule 3. Name the anion. Oh, most of you already know it's oxygen. If you don't, it is oxygen. Oxygen goes to I. So this is iron 3 oxide. Done. See how easy that was? That's all there is to it. 3 simple rules. Yes or no questions. Follow exact steps. Look at this. Read that. Write and follow. Big bam boom. Okay? Perfect. All right. So far, so good. And like I said, if there was some little question, by the end of the day, this will be in Schoology. It'll say, flip chart, rules, naming, lecture to review if you need it. You'll always have it. I'll put it in there. Okay? And this is exactly live what you're seeing here. And if you got it down, great. If you need a review, there it is. If you like that. So it's always there after you leave this class. Okay. So now let's just real quick get the rules down for the middle flip chart, which was the molecular 1/covalent. All right. So now we're going to lift up the middle chart, and we're going to look right here at this tab. One simple rule with a couple exceptions. So it says in the middle flip chart. So I'm looking right here in the middle little thing, flipping it up. Okay, writing everything right there. First things first, I'm going to name as you see it. Name as you see it. Oh, it'll make sense, trust me. Name as you see it. Add prefix. Name as you see it, add prefix. Okay? And then I put a little arrow there. You then will also add the prefix, the reminder, to the cation and the anion. Well, we already know what that is. That's the first and second element of the compound. Well, that's easy. There's no crisscrossing here. There's no Roman numerals. I'm naming it what I see. And then I'm going to, these are my prefixes, 1 through 10, that if it has a whatever number it is, that's what I put in front of it. The only special rule is I never put mono on the first element. Here's your example. Let's see. Okay, here's 2 examples we're going to do real quick. Okay, let's do this right here. CO2. First things first, I look at the first element. Is C on this side or this side of the stair step? It's right here. So it's on this side, right, guys and gals?
Yes.
So I'm doing my new rules. Boom, bam, boom. So, right here. Name it as I see it. Okay, Myers said. So what is C is carbon. He said, name it as I see it. So carbon. And add a prefix to it. How many carbons are there? 1, right? Because it's just C by itself. But what's the special rule say? Do not use mono prefix on the first one. So it's just carbon. What's this one? Oxygen. Oxygen goes to oxide. What prefix do I have? So there's 2 there, right? And don't crisscross it, just name it. What's the prefix for this 2? Di, yeah. So here you go. Carbon dioxide, which you already knew that you're breathing it out right now. That's all it is. I named it as I saw it. I didn't have to do any special rules. I didn't crisscross. I didn't move any of the numbers. I said, okay, there's carbon. Carbon's by itself. So I don't call it monocarbon because carbon's the first one. You don't use mono on the first. Okay? So it's carbon dioxide. Okay? Pretty simple. All right, how about this one? N3O6. Same thing. First thing I ask yourself is N on the left or right? Well, of course, because we're practicing this. There's N. It's on this side of the stair step. Name it as I see it. Add the prefixes. So, that's nitrogen. What is the prefix for 3? Tri. So it's going to be tri-nitrogen. Name the anion with the prefix. O is oxygen, goes to oxide. What's the prefix for 6? Hexa. Hexa oxide. We still do the IDE. That was easy. See how that is? I just named it as I saw it. Those are so easy. So that's tri-nitrogen hexa oxide. No new rules, no crisscrossing, no Roman numerals, nothing. Okay? Whatever rule, just so I said there. Okay? Let's do one more since we're so fast. Let's go with let's go, let's do this. S4 S4I6. Okay, same thing. S4I6. S is on this side. There it is, sulfur. This side of stair step. Name it and put the prefix that's corresponding. So there's a 4, so what's the prefix for 4? Tetra, like the game. Tetris, tetra. Tetra, sulfur. That's the name of the compound. Sulfur. S-U-F-E-R, right? Sulfur. Second one is iodine. We'll go to iodide. What's the prefix for 6, as we know? 6, right there. Hexa. Hexa. Iodide. Iodine goes to iodide. D-I-D-E. That's it. So S4O6 is tetrasulfur hexaoxide. Done. And that's enough for today. So you see how easy even naming covalent compounds. Name it as I see it. Here's the prefixes you use. Never use mono on the first one, and that's all there is to it. And on Monday, I'll have everybody in here, and we're going to jump in with both feet and start practicing. Okay?